Welcome to the AI for Technical Writers podcast. This is episode 99. I'm Fred.
And I'm Daphne. We're here to help you, unpack the biggest and maybe the most expensive developments shaping our field.
Definitely expensive. And these are developments that really demand a complete rethink of skills for technical writers, documentation specialists, IT pros, everyone, really.
Absolutely.
Today, we're focusing on this massive initiative. It's not just another infrastructure project, is it? It feels like the physical side of the race towards AGI. We're talking about the Stargate AI project.
That's right. And we're drawing on a really insightful, updated article by our own producer, senior technical writer, Curt Robbins. The article's called Update Current Status of Stargate AI Project. It just came out September 30, 2025. And it really details the colossal scope of this thing.
Colossal is one word for it.
It gives us a pretty rare look into what sounds like a $500 billion logistical, maybe nightmare or challenge anyway.
$500 billion. That number just sounds staggering. So when we talk about the Stargate AI project, what exactly is it? I mean, what justifies that kind of money?
Okay, so at its heart, Stargate is this multi-phase plan. The goal is to build an AI supercomputer that's just way beyond anything that exists now. This isn't just, adding more servers to the cloud. It's supposed to be a totally new kind of architecture. And yeah, the rumored cost is getting close to $500 billion.
Wow.
The justification, or the why, is really about raw power. Computational power needed to train what they call the next generation of frontier AI models.
Frontier models, like the ones needed for breakthroughs, maybe AGR.
Exactly. Models that could do things that are just impossible right now. It's seen as the key to unlocking, or at least enabling, AGI.
So it's basically a giant engine required for that next leap.
Yeah.
And who's teaming up for this? Who's writing the checks?
Well, it's a really interesting partnership. You've got OpenAI, Oracle, and Japan's Softbank, a powerful trio. They first announced it back in January 2025. And it seems pretty clear they believe the main roadblocks now aren't theoretical AI problems, but physical limits. They just need more raw compute power. More than, the entire world currently uses for AI training, all in one place.
That's hard to even picture. Okay, so they've got the vision, they've got the partners, presumably the money's lined up. But Curt Robbins' report says, where are they today? Late 2025. Are they actually building this thing yet?
Well, that's what's so interesting. Despite that huge price tag, the project is still very much in the foundational stages.
Foundational, meaning?
Meaning they're focused on solving what the article calls monumental infrastructure challenges. The supercomputer itself, that's still years away from being turned on. Right now, it's all about getting the groundwork right.
Okay, monumental infrastructure challenges. Given who's involved, OpenAI, Oracle, you'd think maybe the big hurdle would be, I don't know, getting enough specialized chips. Right, we hear about supply chain issues all the time.
Yeah, you would think so.
But the article specifically points to power as the main obstacle. Why power?
Because the amount they need is just off the charts. It's beyond what any existing power grid can realistically supply to a single project like this.
How much are we talking?
The estimate is multiple gigawatts.
Multiple gigawatts.
Yeah. Think about that. That's like the power consumption of a major city.
For one computer system.
Right. Dedicated entirely to one computer. So the existing infrastructure, the thermodynamics, it just can't handle it.
Okay, wow. Multiple gigawatts. That means they can't just plug it into the wall, obviously. They need completely new solutions. Does the article say how they plan to get that kind of power?
It does touch on that, and this is where it starts to feel a bit like science fiction. That huge energy requirement has apparently forced them to look into novel energy solutions, and that explicitly includes exploring the possibility of dedicated nuclear power generation.
Dedicated nuclear power.
Just for the supercomputer.
Just to run an AI. Okay, that single detail, that really puts the scale into perspective, doesn't it?
It absolutely does.
And for our audience, the IT pros, the tech writers, the amount of regulatory and safety documentation for that alone must be immense.
Oh, absolutely. So the focus right now, it isn't really on coding the AI. It's on securing the physical space, the land, and crucially the energy. That means, architectural planning, sorting out massive supply chains for custom hardware, and really importantly for technical writers, navigating all the complex documentation for environmental rules, land use, regulations around getting gigawatts of power, especially if nuclear is seriously on the table.
Right. So the supercomputer build is still down the road. Phase one is basically securing the foundations.
Yeah.
Land, power, architecture. And this complexity, this infrastructure need, it leads directly to the physical build-out. the data centers.
Exactly. Before we get into the actual locations and the geopolitics, maybe we should take a quick pause.
Good idea. Let's take a brief break for a special message from our producer, Curt Robbins.
Hi, this is Curt Robbins. First, thanks for listening. I truly appreciate your support. I want to let you know that I'm currently accepting new clients. My rates are affordable, and I have more than 25 years of experience working for enterprise companies like Microsoft, Northrop Grumman, Oracle, PNC Bank, FedEx, USAA, and Wells Fargo, among many others. If you want to improve your IT documentation and communications, hire me. I deliver fast, know how to use AI to improve efficiency and accuracy, and love going the extra mile to satisfy my clients. Thank you for subscribing and listening. Back to you, Daphne and Fred.
Welcome back to the AI for Technical Writers podcast. Before the break, we were talking about the incredible energy demands for the Stargate project.
Right, multiple gigawatts.
Which naturally leads us to the physical footprint. Phase 1, according to the source article, is building these huge AI data centers.
Yes. And there was a Reuters report, September 23rd, that confirmed 5 new AI data centers are planned across the U.S. This is the literal foundation they're laying.
5 new centers. Okay, where are these going up? This must involve a lot of different locations and rules.
It does. So OpenAI and Oracle are building 3 of them. One's in Shackleford County, Texas, another in Dona Ana County, New Mexico, and there's a third one somewhere in the Midwest, but the exact location hasn't been disclosed yet.
Okay, Texas, New Mexico, Midwest. And the other 2, that involves Softbank too, right?
That's right. Those 2 centers are a team effort. OpenAI, Softbank, and a Softbank affiliate company. They've picked locations in Lordstown, Ohio, and Milam County, Texas.
Ohio and another one in Texas. Okay.
So right there, you've got 5 different sites, likely 5 different sets of state and local regulations, probably federal oversight too, all needing coordinated documentation across 3 huge corporate partners. That alone is a massive technical writing challenge.
Yeah, the coordination must be intense. I remember Larry Ellison, Oracle CEO, gave some specifics back in January about just how big these buildings are.
He did. He used the Abilene, Texas site as an example to really illustrate the scale.
What did he say?
He said each building is 500,000 square feet.
500,000 square feet per building.
Yes, and they're currently building 10 of those, with plans to expand to 20 buildings eventually, plus more locations.
10 500,000 square foot buildings.
Oh.
Just to start. Okay, for technical writers listening, what does that mean in terms of documentation? We're not just talking software manuals here.
No, definitely not. Think about it. 10 huge, distinct buildings. That means site-specific security plans for each one, environmental safety procedures, disaster recovery plans for facilities using potentially gigawatts of power, detailed standard operating procedures, SOPs for physical maintenance, for security patrols across different states, potentially different climates. It's documenting the physical plant on an unprecedented scale.
The scale really dictates the scope, doesn't it?
Yeah.
It shifts from documenting product features to documenting almost governance and operations of critical infrastructure.
Precisely. Which brings us to the why. Why are these companies pouring $500 billion into this massive public-private, well, mainly private, but nationally significant project? Sam Altman at OpenAI has been pretty clear about the big picture driver.
Yeah, he emphasized that AI needs massive amounts of infrastructure, power, computer chips, data centers, and he really stressed that the U.S. needs to lead this build-out, keep it domestic.
And that's the strategic angle, right? While Stargate is a private venture, it's definitely seen by many as a critical piece of national infrastructure. It's happening against that backdrop of intense global competition, especially with China, over who leads in AI and technology generally. So Stargate gets framed as vital for securing America's lead.
So there's the competitive geopolitical side. But Larry Ellison also talked about a more human payoff, didn't he? A really specific, maybe game-changing application for all of this computing power.
He did, and this kind of connects that abstract goal of AGI back to something tangible, something that could really benefit people directly. Ellison specifically mentioned using AI for a universal cancer vaccine.
A cancer vaccine, how would that work?
Well, the idea he outlined is, first, detection. Apparently, tiny fragments of tumor circulate in our blood. With the kind of power Stargate represents, AI could potentially analyze simple blood tests to find these fragments much earlier than we can now. Imagine cancer detection becoming part of a routine blood screen.
That would be revolutionary for diagnostics and the vaccine part, the therapeutic side.
That's where the massive computation really comes in. Ellison suggested that once a specific cancer tumor is found and its genes are sequenced, which itself is a huge data task, an AI running on Stargate could potentially design a custom vaccine. personalized just for that individual to target their specific cancer. It vaccinates you against your cancer. That's the vision.
From early detection via blood test to a personalized vaccine designed by AI. Okay, that kind of potential impact helps explain the willingness to spend $500 billion.
It certainly provides a powerful why.
So let's bring this home for our listeners, the technical writers, the IT professionals. The source material called Stargate, the physical manifestation of AI's next chapter. What does this huge infrastructure project demand from us, practically speaking? It's more than just writing user guides, right?
Oh, much more. The documentation challenge here is really unprecedented because of the scale and the goal. Since Stargate is seen as a prerequisite for AGI, the documentation has to cover critical new ground. I'd say 3 main areas: security governance, complex regulatory compliance, and architectural clarity for all this custom hardware.
Okay, let's break that down. Security governance.
Yeah.
You mean more than just network security?
Way more. We're talking about documenting the physical security for these massive data centers across multiple states, potentially powered by nuclear reactors. The documentation needs to integrate everything: physical security SOPs, cybersecurity plans for protecting not just the infrastructure, but the frontier AI models themselves, which become national assets, and all the compliance reporting needed for agencies overseeing critical infrastructure.
So technical writers become architects of security documentation for national assets.
In a way, yes. And then there's the custom hardware aspect we touched on.
Right, the bespoke system Softbank or Oracle might be developing.
Exactly. If the chips, the cooling systems, the power distribution, if it's all custom built, we are the ones writing the manuals. The documentation that lets other engineers and technicians safely install, troubleshoot, maintain, and eventually upgrade these unique systems. It's about translating incredibly complex, novel engineering into clear, precise instructions that directly impact safety and operational security.
So our roles are fundamentally shifting. We're moving from documenting, say, commercial software products to documenting regulated critical national infrastructure designed to unlock AGI. The quality, the precision of our work.
Yeah.
It directly impacts safety, accessibility, even national security. It's a whole different level of responsibility.
It really is. The stakes are incredibly high. We're essentially defining the documentation standards for this next era of computing. Standards that have to grapple with power generation, complex regulations across jurisdictions, and the security of what might be the most powerful computer complex ever built.
It's a massive challenge and a massive opportunity for the field. Thank you for listening to the AI for Technical Writers podcast, where we help you get smarter than your competition.
Remember to like, subscribe, comment, and share. We'll see you next week.